So, I only have 69 slides, so don't worry about it. You think I'm kidding. So, we've talked about a lot of things all day, and I want to bring it down to some other things, like software in people, software in vehicles, software in the building. It's not just the software on your laptop or your phone or your corporate capabilities. So one of the biggest problems is now all of our things are connected. Well, that's not new, but it's not just connected as in physically connected. It's somebody's software is doing something, and if it doesn't do what it's supposed to do, you're not going to get the signal to do what you're supposed to do. Or they produce something and it becomes part of your systems, supply chain. So we basically have a lot of things where we're dependent on other people, other organizations. And the question is, how do you gain confidence that they've done what they should do? I mean, within our walls, we can do things, but how do we actually communicate to others, and how do others communicate to us? So a lot of my work is around that type of problem. The other issue I've found is when I talk to senior leadership, they don't actually appreciate how much software their organization has. And I'm not just talking about, the IT centers. So what I try to do is I talked about my first car. My first car had no software in it other than the driver. And it was done with mechanical linkages. So when you hit the accelerator, that's what happened. Well, now there's a sensor, there's a network, there's software, there's protocols, and hopefully it all works. Well, the other thing is that car had point-to-point wiring for signaling and power. Well, that's heavy stuff. And so they said, hey, I can get rid of all that heavy stuff. And oh, by the way, all that heavy stuff, I had to have exactly the right wiring harness for the right version of the right vehicle, and it had to be there at the right time. So they had a lot of inventory problems. So they put in networks, and they put things on the network wherever they wanted. They didn't say, hey, you know what? We're going to make that next car better. We're going to put software everywhere. That wasn't what they were trying to do. They were just trying to make it more economical, make it less weighty, make it more flexible. If you don't have to put the linkage between the pedal and the throttle in a certain place, you can start moving things around in the engine compartment. So these things weren't motivated by what you would say is, oh, they wanted more software. But today, you have a lot of software in a car. In fact, you have a lot of software and a lot of networks. In fact, you have even more networks than you think, and there's going to be more in the near future. But it's not just networks in the car, it's also external connections. How many people remember the low tire pressure problems we had a couple years ago? Well, the solution to that was to put sensors in the tires. And you're not going to wire it into the dashboard. You're going to put a radio in there, and you're going to have a network. So there's lots of these, so now your attack surface is expanded. Here's all your software. When do you do an update? How do you know you got the right update? Who signed it? Who's authorized it? Do you do it while you're going down the highway at 70 miles an hour? Do it in the garage? Take it in for service? Those are all open questions. And we're connecting cars now into other cars, into the traffic systems, into the roadside systems. How do you make sure those are all secure and locked down? Now, I've been talking about vehicles, but vehicles isn't the only vertical industry that's taking these same motivations. So aeronautics, shipping, building management, healthcare, all of them have similar motivations and similar transformations. They didn't say, hey, I'm feeling lucky, let's put software into our core capabilities. They were trying to achieve something, and the software came along with it. Well, they don't even understand what they've done, never mind are they managing it. Even in our critical infrastructure, weapons systems, so on. One of the big things that's changed is now you have software that can kill people. You have software that can take out half a county because it did something wrong. So the idea of how severe a vulnerability is, or some hazard, has a different scale that most people who are software developers have no cognizance. They have no idea how to deal with it, never mind how to communicate with people about it. So one of the things I've tried to do is not talk about risk, because when you talk about risk, it all goes to dollars, and somebody tries to sort, the different dollar impacts. But some of these are a little more special than others. And so in my work in the Industrial Internet Consortium, we've been basically talking about quality gaps. And we focused on 5 of them. So security is up there, but so is safe behavior, reliable, resilient, and upholding privacy. And the reason those 5 are there is they interact. If you've got a product and it's going to be having requirements in those 5 areas, and you have 5 different teams working on it, you're going to have a disaster. You need to actually make them work together. So you really have to focus on how much of something you need, of what kind, and not just come up with some checklist that says, I need all of this. It's really contextual. So what we've done in the Industrial Internet Consortium is we've come up with this diagram. So you see the 5 capabilities. Those are kind of little balloons. They may be smaller or larger for a particular product. We've got this idea of trustworthiness wrapping around them. How many of you, if I asked you to go get a trustworthy cab, and while you're walking to the front door to, hail that cab, I asked you to think about a trustworthy nuclear power control system. You wouldn't have any trouble with me using the word trustworthy in both, even though one of them, you're going to expect a lot more data, a lot more analytics, a lot more rigor in, the criteria versus, touchy-feely things. So trustworthiness seems to be a very contextual word that a lot of groups can get behind. Yes, I need a trustworthy product. It has certain constraints depending on what it is, how bad the downside is. So it's a very useful thing. We've also put the 4 different kind of impacts, everything from environmental disturbances, human error, system faults, and attackers. Because when you talk about safety, security, reliability, resilience, and privacy, some of those specialists don't consider some of those other impacts. But when you're out in the physical world, all of those are possibly going to ruin your day. Now, if you, the Industrial Internet Consortium is basically trying to take all these different areas and many more and come with one marketplace. Traditionally, these have been different markets. They've had their own supply chain, their own group of vendors and maintenance personnel. But now that they've put software-enabled and connected things in them, they're actually the same ecosystem. They're the same level of problems. Trouble is, each of them is clueless as what to do. So by bringing them together, hopefully we can bring some more consistency and sharing of ideas. There's another consortium out there called the Industry Platform 4.0. It's out of the German government. They're mostly focused on manufacturing, but if you think about it, what do manufacturers do? Well, they produce the goods that go into all the other industries. So we work very closely with them. Some people thought we were actually competitors, and no, we're collaborators. So if you need to, you can go look at the architectures that we've both put out there, but you don't have to comply to both. If you do comply to one, you're automatically going to be complying to the other because we've made them consistent. So when you get down to trying to figure out, well, what requirements should I be trying to meet to be trustworthy for a device? One you want a dashboard that shows them so that as you make choices, you know what the interactions are. The other is there's lots of sources of information out there for these types of requirements. Please don't try to apply any of them verbatim, because most of them are not really appropriate for these kinds of devices. So how do you go about choosing those? So going to move away from security for a moment, because I don't want an argument. But let's get into safety. I am not an expert, and I stayed here, so I wasn't in a Holiday Inn last night. But if I was trying to pick some safety requirements for an implantable pacemaker, maybe I'd try to do these kinds of things, right? So there's some set of requirements. Whether these are the right ones or not, we can discuss at the luau. Here's another type of implantable medical device. It's in a different area, so it may have slightly different requirements, sorry. And let's go to a medical environment that you would actually think there'd be some similarity in requirements for safety. Well, actually, there's not. There's a little bit of overlap. And what we don't want to do is say, oh, here's all our bit piece requirements, so let's make a checklist out of it. Because different devices are in different environments and have different failure modes, different contexts, really you have an infinite galaxies of requirements. Could be unique. Of course, how do I manage that? Every single product has different requirements. Every team has different requirements. How do I do that? Well, I would look at what the medical world has done, and actually they have families of products. So for instance, insulin pumps, maybe all of the insulin pump or related technologies have some common requirements. How do I represent those? How do I get a repeatable process? Well, if you again looking in the medical device, assurance cases is the idea. So if you're not familiar with them, real quick tutorial here on them, but basically it's a way of organizing what you're doing, why you think you did enough, and why you think you can say you're done. So a lot of different organizations are using those, a lot of different domains. Basically, I'm making some big claim, and I break it down into things that I can put evidence against. So if I want to say it's remotely safe, it's not attackable from the exterior, then I would want to say what kinds of remote attacks, vulnerabilities have I eliminated, what kind of tools, techniques, and methods have I used to do that, collect all that. The big part is the assumptions and prerequisites. You're making an argument that this thing is safe, but what are the assumptions? What is the rest of the system or the other capabilities doing in your enterprise to make your assumptions true? So you can use it for figuring out if a air wing is ready to do combat. This is the UK. This is for aircraft. And the key of this here is you can actually break it into components. And as long as the subcomponents, assumptions, and prerequisites are honored and reinforced by the parent system, you can compose these. And that's something we've not seen in products, is the composability. So this is a very interesting and it looks like it's going to work. But I want to go back to this. So all of the automotive things, they just carelessly brought in technology that they didn't understand. Well, when we think about that, as software developers for IT systems, we test our systems on a certain configuration, and then it gets shipped to run on lots of other configurations. So we're not tracking what versions of chips, what versions of firmware, what versions of the OS, what versions of the applications, what versions of the source code, the libraries, the frameworks, the compilers, language specs. Yet now we're getting into this OT world, and those things could matter. So I think the tolerance for these areas is going to change. So the idea here is trying to get a bill of materials type of structure on these. never mind services. So this little part of it here is actually what is being talked about for software bill of materials. Think about the software bill of materials is you've got this contractor and the people providing to them, but beyond that, they have very little visibility into what they're getting. So the idea here is to try to, dig away at that obscurity and get some transparency. In fact, the work in the NTIA at Department of Commerce is actually talks about market transparency. So we had a lot of talks earlier that mentioned parts of this. What it really comes down to is you're trying to understand, the stuff that one group produced is used by another. Well, I'm down at the bottom. How do I know I got everything? So what I'm offering is really you need to focus between a particular developer and a particular customer, just one leg. And I've got a bunch of use cases here that have been put together. And the idea here is that a software bill of materials may want to support these kinds of use cases. So, being able to identify something that's being, talked about, referred to, you're acquiring it, you're transferring it, the pedigree. How was this thing put together? The provenance, the chain of custody of it. So a lot of details in this, and this is where we're trying to be very specific about how you would use a software bill of materials. Some of these, like the license management and the patch currency, the bill of materials doesn't have the details about the patches and the licenses. Some external source has that, and you're just mapping it and using it to keep, well, I have this. I can look up in this resource. So there's a lot of confusion and discussion about software bill of materials, and we're trying to get it to be a little more succinct, because when you get down to it, you want the markets to be able to use this. And the way we're doing that, and this is, between tiers, across tiers in a market, if your provider has the ability to give a software bill of materials, that's up to your agreement with them. It doesn't mean it's going to be the default. The other thing is a lot of people have talked about software bill of materials coming from tools that they apply to code they already have. We're talking a lot about the tools that you use to develop software. And the idea here is that as you develop software, the software bill of materials comes out of those tools, not something that you do on top of the products you already have. So when I look at this type of a thing, there's certain data fields that have been talked about, and the next set of slides here basically say for which use case, which of those fields seem to be, needed. So the idea isn't, just build a big catalog of data fields, but rather for different use cases, there's things that may or may not be needed. And in the interest of time, I'm going to go right through those. So we're actually trying to come up, with a standard that would just be those things. So the idea would be that you could buy tools that could conform to this. You could put people on contract to provide it. And I wish I had more time to talk about this, but basically, if you think about the building trade, they had 4,000 years of head start on software. There was a king 4,000 years ago who said, if a builder builds a building and it falls and it kills somebody, the builder will be put to death. That's called accountability. We don't have that in software. Jake was talking about it. We've been talking about it all day. In fact, in software, we don't, it's all made up. In physical things, there's Boyle's law, Planck's constant. Things are, not going to change overnight. With software, you get a new version of compiler, a new version of the library, the software could work totally different. And so, we got the EULA. So I think there's a lot of maturity needed in the building of software and the vetting of it and the due diligence. So I'm going to wrap up here. The bottom line is on the right, you have impact to mission. And it's not magic how either hazards or attackers get from one end to the other. They have to do some type of patterns of attack through weaknesses, but there's a lot of things you can do to mitigate and kind of manage that risk. So the question is there a path through? And that's what the job of the development group is, to make sure they understand the possible paths and what they've done to vet it. So another way of looking at that is you got threats, vectors of threats, weaknesses. You can try to eliminate weaknesses. You can try to mitigate weaknesses. At some point, you decide, have I done enough? And if I have, then you go forward. If you haven't done enough, then you have to treat it as a vulnerability. And then the question is, can I patch it? Or is it something that I need to actually let go out into the world? And then I can try to block it from attack in the infrastructure. I can try to alarm for attack. But if I'm working in that kind of IT enterprise, I've got lots of tools that can help me block from attack or alarm from attack. But if I'm talking about an automobile or the IoT, I'm kind of stopped at that top part of the pyramid. I don't have all those other tools. You don't have that kind of network infrastructure, bandwidth, capabilities. So, there's a bunch of things out there to help you assess that end of software. We've talked about it. They're out there. And the bottom line is you want to know which weaknesses are going to have the most impact on your ability to do for the software to do what it's supposed to do. And once you have that, you can do lots of things. But this is what tools are. Black is the tool found the vulnerability. Bottom line, there's a lot of white. So what it comes down to is you have lots of things you can look at to assess the quality of code for security, safety, reliability. There's lots of different detection methods you can put against it, whether it's manual or automated, but they all have specific scope. They don't do everything. So the question is, the things you care about, do they do those? So if you actually can line that up for your project, that you know you're getting the right kind of evidence about the things that would undermine your system, well, that can be part of your assurance case. That's how you organize all of that. So I had one more thing I wanted to say is, I don't know if you realize that CWE has just got expanded. We added a whole bunch of new quality issues, basically 137 new reliability, performance, maintainability weaknesses, because a project can fail not just because of security. So the idea is a lot of the static analysis and dynamic analysis tools out there find these things, but they had no way of correlating or bringing them together. So the title of my talk was Supply Chain. So I have a couple slides on supply chain. I'd love to talk to you about supply chain. One of the big things about it is it actually has to fit together in your organization. Software supply chain is different than your logistics supply chain. And so getting it placed in the right context is something every organization out there is doing a quick growth and learning on, because they just haven't been able to deal with it. So there's some information out there in CAPEC about supply chain attacks. And the last thing I want to talk about is, as we do assurance and try to be able to convince people, we can't have different approaches in different parts of industry, because every part of industry talks with every other part of the industry. So we need standards that actually work across the whole landscape. And what we hope is that hardware, software, services, you can actually have assured products so that you can actually tell people what you've done to vet it before they look at it. And with that, this is a paper that talks about a lot of that, not all of it. And I think we're well over, but thank you for your time.